Beautiful. All right, let's go ahead and start taking a look at our warm-up question here. So we want to know what is the frequency of this wave right here. So that means that we need to find the number of cycles in 1 second. All right, so if my first cycle starts right here, point for me on the board, where does that first cycle end? Again, we need to find after a first bump and a second bump. Point on the board for me, where does that cycle end? Yeah, awesome. I do see you had the correct answer, right? So this is the end of our first wave, right? So from here to here is our first wave. Go ahead and now show me up on the board again, where would be the end of our next wave? Again, find a top and a bottom bump and tell me where would be the end of our next wave. Excellent. I see red on the board, purple working. Find a top bump and a bottom bump. It should be where it repeats, right? A cycle repeats. Beautiful. There we go. Yes, awesome. So I saw people up there. Yes, this is going to be the end of our second cycle right here. So if we have 2 cycles in 1 second, then our answer should be what? Tell me in the chat in the units Hertz. What should be our answer here? Go ahead and tell me in the chat using those units Hertz. Yeah, exactly. So this would therefore be 2 Hertz. Go ahead and give me a smiley face emoji in the chat if that if that review from yesterday makes sense. Again, once you know the number of waves in a second, that also tells you your frequency in Hertz. Amazing. All right, again, make sure you're getting those notes open. I'll send out those links again in the chat and start raising your hands, and then we're going to go ahead and go over announcements.
So good morning, everyone. As always, please don't share any personal information during class. All right, we are still requiring your participation as always, and we are still also recording these sessions for educational purposes. All right, we are on Wednesday today, doing our 3rd lesson of the unit. Tomorrow is Thursday. As a reminder, it is a recording day, and it looks like we are using that to complete any missing or failed work. So please be sure, the more wisely you can use your time tomorrow, I guarantee you the better your grade will be looking in the class. And then on Friday, we will pick it up with one last lesson to end off the week. All right. For our lesson today in Unit 4, we are calculating frequency and period. So we learned already a little bit about frequency, but period is going to be something a little new to us. First, we're going to define the word period and determine that from a graph. And then we're going to compare frequencies and periods together, see how they increase and decrease respectively. And then we're going to use frequency to calculate the period and vice versa. All right, so they will be having a significant relationship with each other. All right, go ahead, use those links at the bottom of the chat to open up your notes. And just as a reminder, be sure to just use your grades tab if all else fails to access your notes.
All right, everyone, so let's go ahead and talk a little bit about this word period or periodically. Go ahead and tell me in the chat, what does it mean to do something periodically? So an example sentence is, I nap periodically. What would that mean if I said that to someone? Go ahead and tell me in the chat. All right, yeah, I would definitely agree here, right? To do something periodically means that you do it every once in a while, right? You do it occasionally. It could mean that you do it repetitively, right? So it could mean that you do it every single day at a certain time, or it could just mean that every once in a while. Awesome. Now, periodicals, for example, are newspapers and magazines that are published at regular intervals. So again, this idea of things are repeating, and they're repeating fairly regularly, right? If I say I nap periodically, that would not be true if I napped once this year and once 5 years ago. That would not be periodically. Smiley faces, emojis in the chat if that makes sense. There has to be some sort of repetition. It has to be happening, you know, more than just infrequently. Exactly. Awesome. And go ahead and tell me in the chat then, what does a time period in history mean? What does a time period in history mean? Again, these are all ways in which we use the word period in our everyday lives, right? And we're going to be learning how this applies to physics today. So what does time period mean? Yeah, awesome, Mallory. Exactly. Yeah, so it could mean something like an era, right? An era, or maybe even like a certain decade, right? If you like the 30s or the 40s or the 50s, that kind of thing. Excellent. So when we think of period, we should be thinking about something to do with time, right? So it has has something to do with time, and it's also something that's happening fairly regularly, and it happens regularly. Okay, so that's kind of our summary here of based on what we already know about the word period, right? This should help us kind of figure out how it's being applied today in our class. Go ahead, give me a green check, orange checks if that's beginning to make sense. We already know a lot of stuff about the word period, something that has to do with time and happens regularly. Amazing. Thank you, Lena, in the chat. I do see lots of green checks. Yeah, the amount of time needed or already used. Awesome, Jonathan. Yep. Cool. My daughter did have this shirt when she was younger that said "I nap periodically," which is great because it's both talking about chemistry. Iodine, sodium, and phosphorus can be used to spell "I nap," and it's also talking about physics periodically. So I felt like that was a good shirt for my daughter. All right, let's go ahead and talk about this. So we already kind of reviewed frequency. Let's go ahead and practice it one more time because frequency will be related to our period today when we talk about period. So first off, again, frequency is just we need to count the number of cycles in 1 second. And I have a second snippet here. So we need to go ahead and count the number of cycles. Go ahead and point for me up on the board again. Where do you see the end of the first cycle? Again, you should have a top bump and a bottom bump. Where do we see the end of a first cycle? Thank you, red. Thank you, purple, pink. Yeah, so there's the end of our first cycle. So this right here is 1 cycle. Let's go to our next one. Where's the end of our next one? Point to the end of our next one. Let's get some more arrows up there. Again, I can't tell exactly who's up there, so Benjamin, Cody, Callie, make sure your arrows are up there. Thank you, green. Yeah, here's the end of our second cycle. Beautiful. I see yellow up there now. What about our next one? Where's our next cycle? Beautiful, yep. So here's our third cycle, and so on and so forth. I think we're starting to get it, right? So here's our fourth cycle. Here's our fifth cycle. Top and a bottom bump. Here's our sixth cycle. Again, cycles mean that we're repeating, right? So every time we have a top and a bottom bump, that we then start to repeat. And finally, here's our 8th cycle. So tell me in the chat then, what would be the frequency of this wave? What would be the frequency of this wave? If we have 8 cycles in 1 second, put that with the units Hertz. Thank you, Shayna. Thank you, Lexi. Amazing, amazing. Let's get some more answers in the chat. Thank you, Matthew. Excellent, Jayland. Yeah, exactly. This would be 8 Hertz. Awesome, because we have 8 waves in a cycle. That means our frequency is 8 Hertz. Perfect. That's going to be the answer to number 2. First box should be the number 8. Second box should be the units Hertz. All right, so first box is 8. Second box is, oops, here we go, HZ for Hertz. Again, don't actually spell out Hertz, just put in HZ, the abbreviation. You have 20 seconds to go ahead and answer number 2 and raise your hands. All right, now period though, yes, I leave on the 24th, exactly, Lexi. Yep. All right, so period, on the other hand, is the time for a single wave to be completed. So I know that these seem very similar to each other, right? We talked about the number of waves in 1 second. Now, period is the time for 1 wave. All right, so we will continue to try to practice this, but this time we only need to look at a single wave, and we just need to see what is the period of time for a single wave. Again, we know period has to do with time, and so therefore this is going to be the one that's measured in seconds. It's a period of time for 1 wave. So what I need you to do, point on the board for me, where's the end of 1 wave? I've already marked the start. Point for me, where is the end of 1 wave? Again, you need a top and a bottom bump because it's got to go to where it starts to repeat. Now, I see some people after the top bump. Keep on going though, move over. Move over, you need to get past the bottom bump. There we go, perfect. Yes, it's going to be right here. All right, this is the end of our first cycle right here. Smiley faces, emojis in the chat if that makes sense. All right, good. So this is our single wave. All right, and now we just need the time for the single wave. So go ahead. I know it's kind of tiny, but read for me from up on the board. How long did it take for this single wave to happen? All right, so take a look here. What do we see here? How long did that time take? How long did that wave take? Thank you, Noah. Thank you, Tim. Awesome. I see Noah in the chat. Again, the units here are seconds. Thank you, Jayland. Awesome. I see Jayland including those units. Thank you, Lexi. Thank you, Itati, Matthew. Yeah, exactly. So the period here is 0.6 seconds. It took 0 seconds for a single wave to occur. Amazing. This is number 3. I feel like we were pretty confident about that. We're going to get a little bit more practice, and then you will need to do one on your own. 20 seconds, first blank should be 0 0.6. Second box should be just the letter S for seconds.
So period, the time it takes for a single wave cycle to be completed. Think of a period of time measured in seconds. Using our pointers, point on the whiteboard. Where is the end of one wave cycle? Right? So like using a pointer like this, point at the end of one wave cycle. All right, awesome. All right, so now in the chat, at least 5 responses, what is the period below? Can we measure that? And all the way at the end here, that's just 1 whole second. So how long is this period? So remember the period is the amount of time for a single wave to go through one cycle. But yeah, so the period here is going to be 0.2 seconds. So go ahead, don't be sure to include your units. It's just a lowercase s for seconds. But I believe the first box is going to be like normal, the number. Second box is going to be the units. All right, this is going to be for number 4 in our notes. Go ahead and I will set up a timer. Be sure to raise your hands as soon as you're ready to move on.
Awesome. All right, so let's go ahead. This one is a complete on your own. Again, you want to find the period, so the time it takes for a single wave to be completed. All right, so again, think about a period of time. Units should be S for seconds. Now, again, as a hint, make sure just find the end of one wave cycle. Again, you need a top and a bottom bump, and then just identify the time. Go ahead and raise your hands for number 5 when you are ready. If you need help, we're in the Q&A area if you want to check your answers. 30 seconds, go, go, go. Let's go ahead and now compare again frequency and period. So frequency and period are related, but they're not actually the same thing. So again, frequency is the total number of cycles in a whole second. All right, so let's go ahead and count those up. All right, so here's my start. Go ahead and point for me on the board. Where's the end of my first wave? Where is the end of my first wave? Find that top and bottom bump. Yes, awesome. So here's my first wave ending right here. Where's the end of my second wave? Where's the end of my second wave? Move on over. Beautiful. Thank you, green. Thank you, yellow, for joining in. Yep, there's the second wave. Keep on going. Where's the next one? Awesome. Yes, yes, yes. Here's our third wave. Thank you, purple. Come on, move on over. And where's our next wave? Beautiful. Yep. And our final wave. So we've got a fourth wave here and our final wave right here. Awesome. So taking a look at this, right, this means that my frequency is what? Again, total number of waves in a whole second. Total number of waves, how many waves did we identify in total here? And again, units for frequency should be hertz. Thank you, Shayna. Thank you, Lexi. Yeah, don't give me a question mark, Lexi. Be confident. You got it. You got it. Awesome, Cody. Yeah, exactly. So taking a look here, we should be ending up with 5 hertz, right? 5 waves in a second, so 5 hertz. Now, period, on the other hand, is just the time for one cycle. So let's just take a look at the first cycle and tell me how long did it take for the first cycle to occur, right? So we need a period of time for a single cycle. What is that period of time right there? I know it's pretty tiny, so try to read that number. You can zoom in. There's kind of a plus sign there, by the way, at the lower right hand of your whatchamacallit, whiteboard. So right there, what is that number? Thank you, Shayna. Thank you, Cody. Awesome, including those units too. So how long did it take for this single cycle to occur? Thank you, Lexi. Excellent, Matthew. Yeah, so we can see here that it takes 0.2 seconds. Now, the interesting thing about this is 0.2 seconds, if you write that as a fraction, that's actually the same as saying 1 divided by 5 seconds, which should make sense because it's taking this 1 second and dividing it by the 5 waves that are here, right? So 1 second divided by the 5 waves would mean that I would end up with 0.2 seconds. So what that means is that frequency and period are actually opposites of each other. They're inversely related, right? So if there are 5 waves in 1 second, then in order to do 1 wave, that's going to be 1/5 of a second, or 0.2 seconds, just like we just identified. Go ahead, give me a green check, orange X if that's beginning to make sense. Again, they're actually opposites or inverses. You just flip them. You literally just flip them. Beautiful, excellent. I see 11 green checks so far, 12. Again, let me know if you have questions. Communicate in the chat if you have questions. Awesome. All right, so that's going to lead us to here. All right, so we saw again that these are opposites. But now let's go ahead and talk about an actual equation, okay? So the equation, just like we saw, frequency is the inverse or opposite of period. So all we need to do is flip them. So if you take a look at calculating period, which is labeled as a capital T, it's going to be the flip of frequency. So it would be 1 divided by the frequency. Okay, same thing if I want to do the opposite. Again, we just flip them. So if I want to solve for frequency, all I need to do is flip it, 1 divided by the period. Smiley faces emojis in the chat if that's beginning to make sense. They're just opposites of each other. They're just opposites or inverses. Excellent. All right, let's go ahead and actually practice this. Make sure you start getting out your calculators either on your phone or on the computer, or you can Google the word calculator. So the question is, what is the period of a 440 Hertz sound wave? So 440 Hertz, tell me in the chat, is Hertz time or frequency? Is Hertz the unit for time or frequency? Thank you, Shayna. Thank you, Lexi. Get some more answers. Cody, make sure you're practicing this. Yeah, this is the unit for frequency. So I'm going to go ahead and annotate this and say that this is frequency. So plugging that in, we have an equation where period T equals 1 divided by frequency. And I know the frequency, so let's plug that in, 440. So in your calculators, please go ahead and plug this in. What is 1 divided by 440? Again, your units should be seconds, should be S for seconds. 1 divided by 440, what would be the period? Awesome. All right, so if I press enter here, I should be getting 0.00227. Now we're going to go ahead and actually include all of these digits just because we want to be as specific as possible, okay? So 0.00227. This last 7 doesn't need to be rounded up because the number after it is a tiny number, okay? So it's just going to be 0.00227. Now this should make sense. If I have a frequency of 440 Hertz, that means I have 440 waves happening in 1 second. And therefore, the period of time for just one of those waves is going to be super, super duper tiny. Smiley faces emojis in the chat if you understand. Again, the period of time here is very tiny because of how big the frequency is. Awesome. All right, so let's go ahead and jump this back over into our PowerPoint and pop this in. So I should be getting, again, 0.00227 seconds, right? 227 or 7? 227. Yep. All right. Okay, let's go ahead and try the other equation. Okay, so this time we want to solve for frequency. So the time for one wave cycle is 0.0047 seconds. What is its frequency? So right here, seconds, is that my period or is that my frequency? Is that my period of time or frequency? T or little f? Seconds, seconds, seconds. Yes, Noah. Yes, Mallory. Yes, Lexi. Yeah, this is our period. So big T for a period of time. And again, we have frequency equals 1 divided by period. So I know my period. Let me plug that in. My computer will let me. Divided by 0.0047. All right. And let's go ahead and plug that into our calculators. All right. So 1 divided by 0.0047 equals what? Again, units here, we're solving for frequency this time, should be Hertz. Should be Hertz. I'll go ahead and show this to you up on the board too, if any of you are visual learners, to help you out with that. So 0.0047. Let me share this up. Awesome. I see Noah in the chat coming in. Yes. Don't forget those units though. Again, this is a really, really tiny period of time, so you should be ending up with a fairly large frequency. If a single wave only takes 0.0047 seconds, then after a whole second, we're going to have a lot of waves. Yeah, beautiful. Thank you, Lena. Thank you, Kaden. Thank you, Mallory. Thank you, Kaden, for adding those units. Lexi, double check those units. Frequency, remember, is Hertz. Yeah, so taking a look here, we should be ending up with 212. All right, 0.76. All right, so taking a look here, I'm going to go ahead and include 2 digits here. But this 6 should get rounded up because there is a big number after it. 5 is a big number. So we should actually end up with 212.77. Go ahead and give me a smiley face emoji in the chat if you're feeling comfortable with this so far. Smiley face in the chat if you're feeling more comfortable with this. Now that we've practiced it a few times. Beautiful. Again, yep, so 212.77 Hertz. Again, this should make sense. If we have a small period of time, then we should end up with a pretty large frequency because they're opposites of each other. Amazing. All right, so this is the answer for number 7. First box should be 0.00227. Please include all of those digits, otherwise the computer will mark it as wrong. Make sure you have the right amount of zeros and your decimals in the right place. Second box should just be the letter S. For number 8, first box should be 212.77. Again, make sure you include all those digits. Make sure your decimal's in the right place. And your unit should be Hertz. We'll go ahead and give you 30 seconds to finish up both of those. Go, go, go. Oh, and sorry, don't forget, I apologize. Number 6, the fill in the blank is inverse. Number 6 is inverse. Capitalization doesn't matter, spelling does.
Purple one on the left-hand side. So the average male's voice has a frequency of 120 hertz, which sounds lower pitched. What is the period of this sound wave? So we're going to take our 120 hertz and we're going to put it where the frequency should be. So it's going to be 120 hertz. Let's do some calculations in the chat. So include 2 more 3s after that first 8. So let's change that to 833. There we go. That's what it should be right there. And then for the typical wave in the sea caused by wind has a period of 8 seconds. All right, now we need to know the frequency, right, instead of the period. So now we just divide the frequency. So if we have 8 seconds, right, we draw an 8 down here, 8 seconds. So 1 divided by 8 should give us what? Go ahead and give me an answer in the chat. Right, we shouldn't have to round this all. Thank you, Cody, Noah. Yes, Lexi. Yeah, it's going to be 0.00833 seconds. All right, thank you, Matthew. Exactly. So this is going to be 0.125 hertz. 0.125 hertz. Awesome. All right, so let's go ahead and use these answers for number 8 and number 9 respectively. So our 0.0083 seconds, make sure that to include units, that's for number 8. And then 0.125 hertz is for number 9, also include units. All right, today, great job, everyone. We were able to define periods and graph them with a wave, and we compared frequencies and periods together, and we found out they're just opposites of each other, no big deal. And we used the frequency to calculate the period and vice versa, back and forth. So go ahead, use your color pointers if you'd like. Go ahead and tell us how you feel about today's lesson. All right, awesome. If you'd like to, tell us the score you got so we can give you a shout out. And if there's nothing else, go ahead, have a great day. We will see you back here on Friday.